So I'm delighted to welcome earthworm and other worm specialist Emma Sherlock, who's based at the Natural History Museum. Emma is an absolute inspiration when it comes to the world of worms, and she's been an inspiration personally for me and helped me develop my skills and interest in earthworms specifically. But today she's not going to be talking just about earthworms. She's going to be telling us about some of the weird but wonderful worms that are housed in the really internationally important collections that are at the Natural History Museum. I'm not going to give you any hints or tips about what she's going to go into, but I know that Emma will wow us because I've been to many of Emma's talks and I've never been disappointed before. So over to you, Emma, to hear about some of the weird but wonderful worms from the Natural History Museum collections.
Thank you very much, Kieran, and I will try not to let you down. That was a lovely introduction. And yeah, sorry, I'm not at my tip-top best today. But one good thing about doing this on Zoom, I guess, is that none of you can catch it. So so that's good at least. But yeah, sorry if I'm not quite my best. But then again, I've got some of my favorite specimens here. So that yeah, that will definitely keep me chipper. And yeah, hopefully I can wow you with some very cool things. So just to let you know a bit more about who I am. So I'm the annelid curator here at the Natural History Museum. I've been here about 20 years, so I'm sort of almost a specimen myself. And yeah, it's a really fantastic place to work. You never get tired of being here. I wish in a way I was able to do this in person, not to give you my germs, obviously, but to be able to open the cabinets and yes, just take you on a little bit of a tour through and be a bit more spontaneous would be yeah, would be my favorite. But then again, I wouldn't be able to I'd have a maximum of 8 of you. So yeah, I believe about 200 people have booked on this, which is amazing. So I'm able to show a lot more of you, a few of the very cool things I have. So one thing that's been very difficult is obviously choosing quite what to show you. So I feel like probably none of you are quite as geeky as me and hang out in comic book shops, but it really made me think. I was like the geeky proprietor of a comic book shop with like, so do I show you like my first editions? So for me, that would be like my type specimens. So for those of you that don't know our type specimens, we paint their lids red. You can see a few red lids behind me. These are the specimens, basically like the first ever. So they're the ones used in the naming and description of the species. So in terms of scientific value, these are our most valuable specimens in the collection. And we're lucky enough here at the museum to have one of the biggest type specimen collections in the world. I think only the Smithsonian and Paris are sort of comparable with us in the number of types that we hold here across the board at the museum. So yeah, we are hugely lucky to have those, and they are, yeah, like I said, the most valuable in terms of science. But then you have kind of your favorite set of characters within the collection, the ones with the best history, the ones with the best personal stories behind them. I'm the annelid curator here at the museum, but I've also been a caretaker of a few other collections when we've been without curators. And for example, I had the sponge collection. I will touch on one of those a bit later on. But I had the sponge collection for a while, and you look at some of the sponges and then sort of have a look at some of the names that collected them. And then I realized one of the sponges I was looking at, it was collected by one of the first people using one of the old-fashioned diving bells. And actually, within, I think, a year or two of having collected that sponge, he went down to collect more. And he actually died because the equipment went wrong. And you just think, wow, the sacrifices some people make to collect us our specimens are just incredible. So yes, basically, it's very hard to pick out some of the best stories, but Sorry about the noise. It's a bit of a, they're renovating all the front of the museum, so you'll get a nice surprise when you come sometime soon. But yeah, sorry, it's a little bit noisy. But yes, I decided I would start with a leech. So the annelids are the segmented worms, as you probably know, and they make up the so it's the marine bristleworms or polychaete worms. That's the biggest part of my collection, and where the museum's got a really impressive research team, and we're going to talk a lot about that coming up. But we also included in that are the oligochaetes. So within that are the earthworms, which, as you heard, are my favourites. Well, my research area. They're all my favourites, of course. But yeah, the area I know most about. And then also included are the leeches. So I decided I would start us off with the leeches. So I've highlighted one leech that I want to tell you all about, but I couldn't not just highlight a couple of others first. So these are just very little snippets of, you know, I'm not going to delve into these ones, but I want to show you. So our leech collection is actually very small. We don't have a great leech collection just because we haven't had any leech researchers here over the years. But even so, we've still got quite a few types, and we've also got some interesting other specimens. So the first one I wanted to show you is, actually that's the second, so I'll take that out now. This is the first one. So I'll hold it up to the camera, but I might just get this out so we can have a little look. I'll be very careful though, because this specimen is one of my oldest specimens in alcohol. So preserving specimens in alcohol only really was a thing from the sort of mid-1700s. And this leech, let me get this out. So you can see it's in really nice condition, a really lovely leech. This leech is a parasite on, or attaches to sharks and rays. But this was part of the collection of Sir Hans Sloane. And Sir Hans Sloane was pretty much the person who brought about our natural history collections. He was basically the first big donor of material. He had a fantastic collection across the board. Botany in particular have got some incredible botanical books and yeah, collections from him. So he was around from sort of the I think it was about the 1650s. I should have written that down. But yes, through to about this, yes, through to it must have been about the end of the 1600s through to about the 1760s. So he was collecting then, and that means that leech that you just saw is, you know, around over 250 years old. So that is just amazing. And
Emma, sorry, if we're not going to use slides, I might stop the screen sharing, because that means that people can see your window bigger with the camera.
I will go on to a slide in a minute, but yes, not quite yet.
All right. Well, all right. Yeah. It should, when we're doing sections with the camera, it'll be better to have the slides off, because then we can see it bigger, if that makes sense. So just to let you know.
Perfect. Yeah, we can turn it off for now, and I could tell you when we need it back on, should I?
Yeah, you'll need to bring it back up yourself, I'm afraid, because it's...
Oh, okay. No props. Yeah, and then this, you won't be able to see this very well, but this is a little fragment of, oh yeah, thanks, Kieran, of Sir Hans Sloane's actual original label as well. So I think for historical purposes, I think that is just amazing. But another very, very cool leech. This one is too small really to see, but just say this leech, I really love bringing it out because this was actually collected on the famous Everest expedition. So this was collected at 7,000 feet. And yeah, this one made it home. But yeah, I think it's just mind-blowing that it was collected on that. What I want to do is find out if it actually got attached to anyone. That would be very interesting. I have had a look in the archives and I haven't seen anything. But yes, at some point it would be good to see exactly how they collected this. Oh, and the other leech I was just going to briefly point out is one where we actually have to keep it in the dark. This is a holotype, so one of the first ever, and yeah, so the first one found, and it was actually found in caves from 1,300 meters deep, and it has to be kept dark or it just disintegrates. So yeah, another very cool specimen from the collection, but not the one I'm going to focus on. So the leech I decided to focus on is this one, and I will get that out. We could show a slide, but actually maybe I'll just I'll just talk to you about it actually, because yeah, I'll get it out of here. All right, and I do want you to have a little think about the size of this leech. So pretty large. And the reason why that one is, I think, important and just incredibly interesting is that this paper was in our collection. And that's just what the slide was really, showing you the paper. Was written about that leech because it was actually removed from the nasal cavity of a soldier from the Dardanelles. And I'm just going to read you a little bit of this paper. So it was collected from him in 1915. So yeah, that exact specimen I just held up was up the nose of yes, he must have had a big nose, that's true. No, I think it was just causing him an awful lot of pain. But yeah, it says here, the patient, who is a private in the army, was admitted to the Beach Hospital, Gallipoli, on August the 21st for shrapnel wounds of the fingers. On August the 23rd, he began to suffer from nose bleeding, I'm not surprised, headaches and pains in the stomach, and was diagnosed with a case of enteric fever. He was transferred to the hospital ship Canada, where he became worse. And on September the 10th, he arrived at the military hospital Tooting, still suffering from nose bleeding, headache, and other symptoms. He was then found also to have contracted malaria, which would have exacerbated some of the symptoms. But after 3 days in that hospital, they did eventually find the leech. And it was absolutely gorged with blood. So I guess that's why it's so large. Obviously, it wouldn't have been that size when it went up his nose. It would have been absolutely tiny. Yeah, and then the patient stated that all the water he'd drunk was from wells. So basically, this paper then goes on. This is actually just to inform other medical professionals, but also the army of what to do. So yeah, it's quite fascinating what they do. So they then were talking about what things to look out for if this happens. So they can actually attach to the glottis, and they can result in a loss of voice and produce dangerous interference with the process of respiration, which does not sound good. And then they worked out the best way to remove them. So the best way was to saturate a piece of cotton wool with 30% solution of cocaine and bringing it into contact with the parasite, at which time it relinquishes its hold and is coughed up. So yeah, I think they might probably find a different way to do that now. But the best thing is that then they were able to inform the armed forces that actually they need to be either boiling their water for troops or using a fine muslin as a sieve, so that then these the sort of the tiny leeches, juvenile leeches, are then able to be sieved out, and you don't get that sort of problem. So yes, this leech here has been able to inform the armed forces back then in World War I how to keep their troops safe from infestation. So yeah, I very much like that leech. But then I thought, as my next specimen, I'll just move on to my slides. I'll share my screen again if it works. Yeah. And move it along. So that was the leech from the soldier's nose. And then I thought I'd move on to something that I found in the collection that then I thought was incredibly interesting, just as, yes, something that it made me learn that I hadn't realized. And that was this particular specimen. And as far as we know, it's the only example known where this behavior has actually been captured in a preserved specimen. So you can see this is not our best earthworm specimen. You can see it's actually been severed, so it's only part of a worm. And this is actually from a collection of earthworms from Ghana, a research collection that's in my unprocessed material cupboard. Yeah, it's kind of a smorgasbord of things. And gradually I'm going through these things. And yes, this was part of a big collection that was collected in Ghana in the 1970s. And a colleague of mine from Hungary came across, and we started to go through the material together. It's not, they're not generally families that I'm so familiar with. So yeah, and I came across this specimen, and I couldn't believe it. At first I thought, wow, maybe it's some kind of very strange regeneration gone wrong. But no, it is actually a carnivorous earthworm. And it was actually back in the 1980s that it was first discovered that there's one genus of earthworms, as far as we know. There could well be more. There's obviously a huge amount we still don't know about earthworms around the world. But yeah, this is there's one genus of earthworms which is actually carnivorous. And the amazing thing is that they've even got internal adaptations to that. So instead of having a crop and a gizzard, like most earthworms do, to grind up that tough plant, dead and decaying plant material, or to grind up the soil, these have much reduced crop and gizzard because it's not needed, because earthworms actually decompose incredibly quickly and pretty much by themselves, because their guts are full of bacteria and things. So they don't need that. And yet they've been adapted to have a little bit more of an angular head end, and they've got setae that are stronger, especially up at the front end and at the tail, and enables them to move much faster. But the coolest thing, when I went through the literature as well about them, is they have a particular smell apparently about them. They've got a real odor, and that odor is supposedly to stop them being carnivorous with each other. So no cannibalism. Yes. So yes, I just wanted to highlight this particular worm, just because, yeah, I really learned something from it, and I think it's very cool. And I guess if I was going back to the comic book analogy, it's kind of a little bit gruesome in a way, just because you don't expect earthworms to be hunting other worms. So yes, I very much liked that worm. But then I wanted to keep on the carnivorous theme, but this time with a sponge, because our deep sea team here at the museum, who I mentioned, worked on polychaete worms. So the marine bristleworms, they do some fantastic research on those. And they were working on this particular sponge. So, sponge and polychaete. So basically what happened was Sergei, who's was part of the deep sea team, was married to Anna, who was our sponge researcher. And he went on one of her deep sea trips. And when he was down helping her collect sponges, he realized that actually a couple of them had polychaetes sort of hidden within them. And yeah, he was mystified by that. He'd never heard of this before. And what was even more interesting is the sponge itself is a kind of a sponge. It actually generally eats things like copepods and, consumes things like copepods. So this was very strange because the worm did not appear to be being consumed. It had little worm runs within and certainly seemed to be happy and protected in that environment. So when he came back from his diving trip, he came to find me, and I was the caretaker of the sponge collection at the time too. And he said, right, can we have a look in the collection? So we went up to the collection, and we actually found a couple of these sponges which also had these worms hidden. And if you can see from the picture, you can see the little polychaete like right within the sponge. I've actually got one of the specimens. We found them from here, not that you can necessarily see, but this is the sponge from the collection. So he was really fascinated by this and ended up doing quite a lot of research. There's lots we still don't know. We don't entirely know if it's a symbiotic relationship or not, or we think potentially the polychaete can sort of help clean the sponge, and for the worm, it gets obviously a lot of protection. So that's the great thing for the worm. But exactly the chemical process whereby these worm runs are able to happen, we're really not sure. And the same relationships happen as well, particularly with the Polynoidae family in polychaetes, which this worm is. It seems to happen quite a lot, that they have these relationships with either a cnidaria, like a coral, or a sponge. Even some crabs they can have some symbiotic relationships with. So yeah, this has been a fascinating discovery, and actually this was found to be a new species as well. So there are a few species which do this, and this particular one ended up being a new species. So that worm is a new holotype. So yeah, that was something I was really excited about. Then another outcome from our deep sea team is something that's very much in the news at the moment. I don't know if any of you have seen the news about the deep sea mining that's potentially going to be starting soon. And the museum have been part of a team trying to ascertain what life is really down in the deep sea, and what potential impact, if deep sea mining is opened up, what the potential impact will be. So first of all, I was going to introduce you to the character. I was also going to bring you the jar, but actually they're working on it at the moment. That's the trials of having an active collection, but I have the pictures. So Neanthes gudae was described in 2021, and it's only found in the polymetallic nodules deep in the deep sea. So I think it's around sort of 4,000 meters, and generally in international waters. And it's actually these polymetallic nodules that are the focus of this deep sea mining. So they are a really distinctive habitat, and they're basically, I'll check my notes for this to make sure I don't get this wrong, but precipitated iron oxides and manganese oxides. And basically onto these is where metals like nickel, cobalt, copper, titanium, and other rare elements all attach. So basically things that people really want for batteries and things like that. This is a very valuable resource. But it's been the focus of a lot of international chat, because it needs to be managed very carefully, mining down there. There are incredible flora and fauna. We don't want to disturb our oceans too much, but I know the UN are now getting involved, and I think there's a way that they're going to try and manage this so that so the third world countries will get money from this if it's sort of managed properly. But that's the big question of how to manage it. But this particular worm, which is a holotype in our collection, was discovered, as I mentioned, in 2021, and it's only found in these nodules, and it's the largest animal that they found so far. And also it's quite charismatic. You can see it's got big eyes, because again, it's a predator. It's got its jaws, which it can push out. So it's it's a recognized, even though it's only about just over a centimetre long, that is actually a decent sized animal to work with. So this is being billed as potentially an indicator species for us to be able to relatively quickly be able to find out in an area if it's been overmined. If we're able to find it in decent numbers, then maybe things are okay. If not, this is very preliminary stage, and that's obviously extremely crude, but it is being billed as potentially some form of indicator species. And this, I was saying how recent it is. This was just March the 15th, 2023, that Diva, who used to work here at the museum and is now working between Trinidad and Tobago and America, but she had an big opinion piece in the New York Times about the dangers of opening up the deep sea mining. So yes, this is quite a topical worm that's in our collections. A strange one, but kind of cute, I think. Then moving back to earthworms. I know, I shouldn't, but this is a very strange one if we wanted strange things. So a paper just got published a couple of years ago about maybe this, which is Dicogaster bulaui, being the first kind of domicile earthworm. So not quite domesticated. I was just playing around with that a little way, but domicile as in dormus as in house, and oh yes, to inhabit house, basically, in Latin. You tell I didn't do Latin. So we've always had peregrine earthworms, which are earthworms which are able to move around and inhabit areas they weren't necessarily supposed to, but they've always generally stuck to their tropic, the temperate zone they're meant to be in. So whereas at places like Kew Gardens, for example, here, we do have worms from all around the world. In fact, oddly, we have quite a few type specimens. This is a type specimen of an earthworm, where the type locality is Kew Gardens, except they're an African species. So very safe, but they just happen to have been discovered at Kew because they've come across in soil and things and then been able to survive. So we have traveling worms in that regard, but this is the first earthworm that it seems is able to inhabit all around the world, because they've been able to adapt to using sewage systems and pot plants. And oddly, I'm showing you this, as we have some from the collection anyway, which I do have here, that they've disappeared. I'll find those. But also, I've just been sent some from IKEA in Dublin, from one of their pot plants as well. So yeah, they do seem to be the first earthworms that are able to survive anywhere, because they are just using human systems. So they're using our homes, which is quite extraordinary. But even more extraordinary, I was then told, is that they're starting to potentially parasitize as well. I think this is probably highly unusual. And they do then go on to talk about some other potential parasitism with earthworms that's just completely not right. But these have been verified. This is written by Rob Blakemore, who's a big earthworm taxonomist. So yes, these have obviously this sort of incident has obviously happened a few times. And when I looked through, one of the original infestations that have been reported was actually then housed here as well. So yes, some very strange goings on with earthworms. Then moving on to the next one. These are oligochaetes, but not exactly earthworms. But this again is like something from a comic book, I think. These are amazing worms. Now, they're not much to look at. You won't really see anything here. They're really, really tiny, these ice worms. I'll just show you how tiny up to your screen, but I don't know if you can see just very tiny brown bit at the bottom of that vial. So these are the ice worms, but they are phenomenal. So the darkness in color is UV protection, basically. That's why they're dark in color. And as I got in touch with the researchers just to see what the latest was with these worms. And they were saying that you definitely need UV protection. If they go out on the ice in the sunshine, you get burnt to an absolute crisp. So they're incredible for having that. These are, they're up to sort of 2.5. They're up to sort of 2 centimeters long in their longest sense. If you really stretch them, but they're only 0.5 centimeters wide. They're really, really thin, and you can get millions of them per meter squared. They come up to the surface when the sun's about to set on the glaciers, and then they eat the algae, and they think potentially pollen grains can get blown over there. So they're generally around Alaska is where you get the biggest amounts of them, the Muir Glacier. And they were first discovered in the 1800s. But the really amazing thing about them is the way they can produce energy. So the way they can make extra energy with it's how the ATP in their body is produced, basically. They're able to get extra energy. So they think 5 million years ago, an ice worm ate a glacier fungus and stole some of its DNA, and then used this to modify how it makes its ATP. And because of this, NASA are really interested in these worms. Because obviously out in space, there isn't much extra energy around. And so they've put a lot of money into working out what these worms are doing to produce this extra energy they need, being in such a cold environment. Because they think it would be maybe interesting to see if that's how things can survive on, in particular, they say Jupiter's moons. I don't know why in particular Jupiter's moons, but yes, they're very, very interested in these worms for that. So I think especially for the size of them, these are incredible little worms to have in their collection. I actually, back in, I think, 2006, asked for these specimens to be deposited here so that we had some. Sorry, I'm seeing the time. I've taken a long time. Sorry, Kieran. There's not too much left, so there will be time for questions. Then the most iconic specimens, I think, to come out of our deep sea polychaete research team here are the Ossidax. So these are the bone-eating tiny worms. And again, they're also a little bit like something out of sci-fi. So our Adrian Glover, our researcher here in 2013, discovered Ossidax mucroflorus, which we have here. This is the holotype, so the first ever. And that is a picture of it on your screen. And these are, the actual Ossidax group was first discovered back in 2002. They saw on whale bones a sort of carpet of what they thought was a plant at first. And actually, when they really looked into it, they realized it was actually worms. And yeah, they called this one that was found in 2013 by Adrian's team, Ossidax mucroflorus, because it's basically, Ossidax is bone-eating and mucroflorus is snot flower. So a bone-eating snot flower, which I think you can see is quite apt. But these are incredible animals, again, for the fact that, yeah, they use the bone. They're able to dissolve the bone because they can produce this acid from this root clump at the bottom. And then they're able to dissolve that, and they can actually then absorb directly the lipids and the collagen from these whale bones. So utilizing an incredible resource. We think also probably other bones. They think back in the fossil records, there are markings even on pterodactyl bones, which could have been from a similar worm. So yeah, it's very hard in the fossil record, but they think these have been able to utilize other bones. And at first they were finding lots of females. So this is the female worm. There's not really much to the worm, to be honest. The plumes at the top are kind of the gills. And then they use this root area to then absorb kind of food. So they don't have, you know, a stomach as such, or a mouth or an anus or anything like that. They're very simple animals. But they could only find females and no males. So yeah, that they were very mystified by this. But in the end, they worked out that the males were just tiny microscopic creatures that lived in sort of little harems within, again, that sort of root clump. So that's why they weren't finding the males. So very, very strange organisms. But we here at the museum have the most comprehensive now collection of Ossidax. So we have the best Ossidax collection in the world. So yeah, we're very proud of our Ossidax here at the museum. And then just the last thing, sorry, I've gone on probably a bit too long, but just I've got lots of other nice things here. They're also big on their vent worms. So these are some big vent worm tubes and things. But the last thing I was just going to mention was just because, again, I thought it was a very, very cool, was that a tiny worm, where have I put that? Oh, now I've put it down somewhere. That's always difficult. But anyway, I've got the a clip of the article. Oh, I think I've lost my present.
Yeah, you just hit share the screen again. Sorry, I took it off because I thought you were going to show it to the camera.
Sorry, that's my fault. Oh yeah, share screen. Sorry. Yeah. It was just in the collection that we have one absolutely tiny worm, which now is so tiny I've clearly put it somewhere. So apologies. But it's about the size of the ice worms, if not actually smaller. Yeah, so I don't know what on earth I've done with that. This is museum curators. We're bumbly creatures. Yeah, so it's tinier than those ice worms I showed you. And yet the specimen we have in the collection actually halted a whole motorway going through in Medway. It's the lagoon worm. And yeah, just almost a microscopic worm, and it stopped a few £1 million project so that then it could be relocated. So just because we were able to prove it was there and in our collections, the area was able to be conserved, and obviously the road still had to go ahead, but we were able to create a similar habitat for it and relocate the worms, so then the road could go through. So I like the fact that it was absolutely tiny, and yet was people did actually respect it, and yes, it had a sort of mighty impact. So yes, I thought I'd stop on the mighty impact of worms. So yes, sorry, I've probably whittled on a bit too long, Kieran, but hopefully there's time for some questions. And just to say, I'm not the expert, obviously, on a lot of these worms, but any questions I can't answer, we have our research team here, and I will absolutely take any questions I'm not sure about straight back to them, and then hopefully via Kieran can get answers back to you if I can't answer them straight away.